Hello, everyone. My name is Rish Kumar, and today I'll be presenting on my project Solana blockchain transactions for AlphaCube. Let's start off by sharing my screen. Okay, so this is the slide deck, and let's click on play. All right. So my name is Rish Kumar, and today I'm presenting the results of a project conducted under the sponsorship of AlphaCube. Focus on uncovering the behavioral patterns behind swap transactions on the Solana blockchain. This effort began with a simple yet significant question. How can we distinguish automated market maker activity from that of organic traders using only on-chain data? Now, in decentralized environments like Radium, where transparency is a given, but interpretation is a challenge. This distinction is not merely academic. It is critical for understanding the true effectiveness and user engagement of liquidity pool and making strategic decisions and market interventions. Now let's move on to the project overview. To address this, I designed a methodology centered around 5 core objectives. Firstly, segmenting transaction history into what we call decision blocks, which are logical partitions in time based on changes in trading activity. Secondly, developing a rule-based classification system capable of distinguishing between market maker and organic trader behavior. Thirdly, extracting and computing key behavioral features from on-chain swap data. Fourthly, validating rule accuracy through statistical analysis and visualizations. And finally, laying the foundation for future machine learning optimization based on target pressure metric and defined by the sponsor, Bogdan. Now let's understand the landscape of this trading environment. On Solana, market makers operate with precision, thousands of trades per day, executed programmatically, often with minimal latency and using priority mechanisms, such as G2 tips. In contrast, organic traders, or as you would say, regular users, exhibit sporadic activity, generally using the web interface and reacting to price changes, often with a few large trades spread over time. However, on-chain data that we get is pseudonymous. There are no ground truth labels, and that's the challenge that we face. So the challenge then was to infer identity and intent from the behavior that we know. So now let's move on to the technical implementation. We began by constructing a custom Java-based parser, which extracted structured data from raw transaction logs using Solana RPC APIs. This included timestamps, Solana balance changes, and categorical transaction flags, such as is Radium swap, is Jito tip, is Bananagan swap, is Radium add liquidity, and several others, which are Boolean flags, which would show one if those flags were true and zero otherwise. These attributes collectively allowed us to map each transaction to an activity profile. Next, using predefined bulk height thresholds, which was given to us by Bogdan, I split the dataset into 8 distinct decision blocks, each representing a meaningful period of trading behavior. I then computed features such as trade frequency, interface usage, SDK versus web, swap sizing patterns, round trip profitability, cheater priority usage, engagement with liquidity pools, and etc. These metrics form the basis of my 15-rule classification framework, a few of which I'll outline here in this presentation. One of the rules which I came up with was if the average trade intervals are below 60 seconds and persist 24/7, we classify them as a market maker. Another rule which I came up with was if the majority of swaps use the Radium SDK and not the web interface, we classify them as market maker again. And if G2 tips are used frequently, it's indicative of advanced strategies, again, pointing to market maker behavior. And conversely, if the world only engages in one-sided trades with no evidence of selling or rebalancing, it's more likely an organic trader. Now, it's important to note here that each rule adds context. No single rule is definitive, but taken together, they form a clear signal. Now, let's see at some insights that we got from the data. As you can see, the light purple uh, bar on this graph represents the SDK usage percentage, which represents what percentage of the swaps were done on Radium SDK, which is indicative of a more market maker or algorithmic trading activity. And the relatively deeper purple bars will show you what the G2 tip percentage was, again, pointing to more market maker activity. And the last, the bluish bar will show you what the average interval was between different swaps. And as you can see, it was relatively small, like in the range of 0.7 to 0.8 for most of the blocks, except the middle block, which represents periods of flow or sporadic activity in that specific block, which was one of the most interesting finds of this analysis. Some other key findings from this analysis was that during the launch phase, the activity was mostly dominated by bots. Trade intervals were in sub-second. Over 83% of swaps was used under the SDK, and more than 38% included G2 tips. In the mid phase, we observed a slowdown. Average swap intervals rose to 70 seconds. G2 usage dropped to 16%, and web usage increased, indicating a rise in organic participation. In later phases, we saw a hybrid structure, while automated market microswaps continued. Web usage peaked at 18.2%. And larger irregular trades re-entered the picture, likely from human participants. Now, our classifications showed that while bots dominated early and late periods, organic traders played a more visible role during the middle of the token's life cycle. Now, what are some impacts and future potentials of this analysis? The rule-based system isn't just descriptive, it's actionable. For AlphaCube, this means real-time differentiation between liquidity provisioning and genuine market interest. A way to quantify pressure exerted by different active types, helping measure effectiveness of market-making strategies, and perhaps most importantly, a platform to optimize classification through machine learning. We've already outlined a pipeline for that, and where I think features derived from rules become model inputs. High confidence rule outcomes act as pseudo labels, and models such as decision trees or XGBoost can be then trained to maximize the sponsor's target metric, whether that's net buy pressure, volatility smoothing, or predictive volume analytics. Now, some final thoughts. In conclusion, I believe this project delivered a structured, transparent methodology, a robust rule-based system for classifying trader behavior, insightful visualizations and some interesting finds, and a roadmap for ML-driven optimization. By translating raw blockchain data into human understandable patterns, we built a tool that can empower better decision-making, market monitoring, and strategic liquidity deployment. It's been a privilege to work on a problem at the intersection of decentralized finance, machine learning, and market microstructure. And I look forward to the next phase of development. Thank you.